Good morning, everyone. I am K. from Mechanical Second Year, roll number 24955A0306. My topic is effect of guideways angle on Pelton turbine performance. Now, firstly, we, we know about the Pelton turbine. A Pelton turbine is an impulse-type hydraulic turbine commonly used in high-head low flow electro hydroelectric plant. So this is an impulse turbine. That means it flows through the it flows it is used at high heads where the water comes with a high pressure and low discharge. The water jet strikes spoon shaped bucket mounted on a riser, which is also called as bucket, convert kinetic energy into mechanical rotation. Throughout, Pelton turbine does not have traditional guideways like reaction turbines. Examples for reaction turbines are Francis or Kaplan. Many modern designs use nozzle deflectors or adjustment steer wheels, often called guide vanes in a broader sense, to control flow rate and jet direction, thereby regulate the performance. Now here in the figure we can see the Pe- Pelton turbine where the nozzle is open, where penstock the water comes from the higher ground. Here it's the bucket and buckets rotates the riser and the discharge is from the tailstock. This is used for regulating the speed. Steer is used for regulating the speed, which is connected with the governance. Role of guideways or jet deflector. In impulse turbine, like Pelton, the guide vane's angle refers to the origination of deflectors or spear nozzle controlling the jet shape, pressure, and direction. Adjusting the angle modulates the power rate and impact point of water on the turbine buckets. This affects runner, torque, rotational speed, efficiency, and water utilization. Parameters affected by the guide vane angle. First is flow rate, jet velocity, impact efficiency, mechanical power output, turbine efficiency. Flow rate decreases as the vane angle becomes narrower. When the gateways angle becomes narrower, flow rate also decreases. So restrict the amount of water reaching the filter turbine. So less water is reaching to the filter bucket. Next is jet velocity. Jet velocity is influenced by the vane angle, where improper adjustment can lead to energy losses and reduce impact force on the turbine bucket. So, if they are misalignment or in the improper adjustment in the vane adjustment, so many energy is lost. Impact impact efficiency depends on how accurate the water jet strikes the center of the bucket. Deviating position caused by incorrect vane angle lead to splash and energy waste. Next is mechanical power output is directly affected by both the flow rate and the velocity of the jet. They are controlled by the guide plane angle. Next is turbine efficiency. Turbine efficiency reaches its peak at an optimal guideways angle while both overlay proper open and overlay closed settings result in lower efficiency due to hydraulic losses and misalignment. So, if the hydraulic buckets or vanes are misaligned, the turbine efficiency also decreases. And if the mechanical efficiency is also decreased, automatically turbine efficiency is also performance impact in detail breakdown. Now, in previous slide, we saw what are the parameter effect in a single. Now, we go in depth. In first one, we see in this, we going to know about jet alignment, bucket interaction, partial load and operation, jet quality and coherence, flow control and efficiency. So, the first, jet alignment and bucket interaction. If the guideway direction to jet too steady, too sleepy, or too shallowy, it misses the ideal impact point of the bucket. So, if it does not hit on the ideal impact point, it does not get, it does not rotate in the required revolution and required rounds. So, efficiency decreases. Misalignment can also cause splashing, energy loss, and poor momentum transfer. Next is partial load operation. At reduced loads, the guideway reduces the jet size to avoid full flow. Poor angle setting in the part load causes lower efficiency, lead to hydraulic loss and unsteady torque. So, due to partial load operation, this partial load means over always adjusting the guides or adjusting the flow. Next is jet quality. Jet quality. Larger deflection angle causes jet, jet breakup due to turbulence. Smooth focus jet insurance between interaction with the buckets and reduces vibration. Flow control and efficiency. At the optimum angle, the jet hits the center of the bucket, hitting the blade, maximizing the kinetic energy transfer. So flow control and efficiency is also main important. At an optimal angle, when the jet hits the on the bucket, it splashes, it splits into two, and this blade is used for splitting. Too narrow or too wide an angle reduces the net head quality of the bucket. Next, here is an experimental and simulative observation. First experiment observation. Maximum turbine efficiency mu 90%, thus at the guideways angle, deviation of plus or minus 10 degrees. From optimal reducing efficiency of 5 to 15%. Improper angle increase water splash and leakage losses. Next is computerized fluid dynamics simulation, that is also called as CFD. Velocity counter shows maximum jet coherence at an optimal vane angle. Pressure distribute over buckets is more uniform with correct alignment. Turbulence and vortex shading increases with the off-angle setting. Next is optimal techniques. Optimal techniques are used for increasing or taking it to the next generation with a very good efficiency and techniques. AIML model can be trained can be trained to predict the best guideway angle under different heads and loads. PID control system. In modern plants, the plants automatically adjust weight position to maintain peak efficiency. Real-time feedback from flow meter and torque sensor helps fine-tune range angle dynamically. Challenges and consideration. The main challenges are wear and tear of mechanical vane actuators, respond time lag in vane movement during transition load, calibration, complexity in multi-jet Pelton turbine. Conclusion. Well, Pelton turbines are type turbines, optimizing they are optimizing the gateways and ensuring the more precision, resulting in maximum energy transfer with reduced load and improve the turbine lifespan. Modern techniques like EFD simulation and AI-based optimization should be included to get more efficiency and max hitting spot. Thank you.